Hi, to start today, I want you to have a go at this question here. All right, first things first, let x follow a normal distribution with mean 150 and standard deviation 10. So that's going to be 10 squared here because it's the variance. Might just write to the left the values just so I don't get them incorrect later on. That's all this wordy information written mathematically. Now find the probability that the length of a randomly selected strip is shorter than 165. So that's going to be our first calculation. Get the old class whiz out. And we get 0.933. Not too bothered if you round it to 3 or 4 significant figures here. Within 5 centimeters of the mean. That's going to be from 145 to 155. Okay, 0.383. Probably given it to 4 sig figs here. No, I didn't. And then more than 20 centimeters different from the mean. I've just realized I've gone straight into this, and I always talk about drawing a little sketch, so I'm just going to backtrack and get these sketches in, so then I can sort of check that they make sense. Okay, so that was that one. And that was that one, just roughly. This third one, more than 20 centimeters different from the mean. So I've got my mean of 150, so it's going to be more than 170, which is here, plus probability that x is less than 130. I can work those out, or I could just do 1 minus the blue area. This is the quickest approach because although you can get this one really quickly, you're going to have to do a 1 minus here anyway. This just ends up being simpler. Zero point 0.0455, which would round up to 0.456. Let's just check, do I agree? No, why did I write that? It should be 55. Brilliant. And the last one, what length are 80% of the strips more than? Okay, so it's going to be down here somewhere, and I'm interested in when this area is 0.8. So I'm solving the probability that x is greater than is equal to 0.8. That's going to be the probability that x is less than a is equal to 0.2. Inverse normal, 0.2. 141.6. Now we have it. A little bit of revision on general normal distributions, modeling questions. It says it's normal distribution, but we're actually modeling it by a normal distribution. Dealing with finding probabilities, dealing with the inverse function. Hopefully you're happy with that little recap. Today we're going to look at calculating the mean and or the variance of a normal distribution. So let's say first of all, I know the variance of my normal distribution, but I don't know the mean, but I've got another piece of information about it. How can I work back to the mean? Well, a good starting point is to draw a little sketch of what's going on. But now I've got to label this as mu, and then the probability that x is greater than 20 is 0.2, so it's got to be this side. I know it's going to be a small area. That shaded area there is 0.2. But if we do the inverse normal distribution or something like that, then I'm in a bit of a trouble with the classwiz calculator because I have to input a value of mu into it. I can't get the value of mu. So how can we go about doing this? Well, there is a way, and what we sort of need to do somehow is change this value here, change it from mu into something that we know, something that we can deal with. So can you think of any normal distribution that you've already dealt with that you know a lot about at this point? You think how you might change this normal distribution that I've got into that one? And the answer, hopefully you did have a think about it, the answer is to let z equal x minus mu divided by the standard deviation. I'm actually transforming this normal distribution into the standard normal distribution. I'm going to minus mu from every single value, and I'm going to divide by the standard deviation. And if we return to the equations of the normal distributions, you can see that it's going to work. I'm going to end up, this thing is going to become z here. And when I do, to be fair, it's when I do the integral that the scaling factor is going to come into play. I'd need to follow through that, to be fair. Then I would get this standard normal. So this is what's going to happen when we plot the new normal distribution. I've still got a normal distribution, but now my value of mu, if I do x, that's every value of the normal distribution. If I do mu minus mu, that's going to be 0. If I divide it by the standard deviation, I'll still have 0. So this is going to be 0. And this point 20 is going to become 20 minus mu over the standard deviation. Now in this case, the standard deviation is 3. So this is my new value that I have. And then because of the properties of the normal distribution, and I've set these on worksheets to get you to prove these things, the fact that for any normal distribution, 68% of the data is within one standard deviation of the mean. It's the reason why we can say for sure that I'm still going to have 20% of my data here. And this is what I can write down. Instead of this formula, I can write down the probability of z being greater than 20 minus mu over 3 is equal to 0.2. Because I've done this substitution. And from this point on, we're basically back to where we were almost at the start of the lesson. We've just got this sort of coded value. We've got this expression in terms of, you can treat this a bit like we did A in the first questions for today. So what I can now do is I can write down a probability that z is less than 20 minus mu over 3. That's going to be 0.8, just 1 minus 0.2. And there we go. Now I can get my classwiz calculator out. 20 minus mu over 3 is going to equal, I'm doing the inverse normal. My area is 0.8. I'm back to the standard normal. I get 0.8416. And I can rearrange that. I'm not going to go through the whole rearranging process. Maybe I will a little bit actually. So 20 minus mu is going to equal 3 times that. So store that number into your calculator, get back to calculator mode. 3 times A is 2.52. Rearrange it, get mu on the other side. It's going to be 20 minus this. 17.475. I didn't write that bit in. Which I'm going to round to 17.5. And that makes sense. It's less than 20. The standard deviation is, it all kind of seems to make sense. Oh, first time you see this, I think it takes a bit to get your head around it. The fact that we're transforming a general normal distribution back to the standard normal. You're kind of trusting me on this. You'd have to go into the integrals to kind of show it exactly. I have set this previously. I'm just asking you to, you can kind of roughly see where it's coming from, and the fact that you can stay as 0.2. The key bit of acceptance, I suppose, is the fact that, if you have this and you do this, then you get to this. And that idea is going to underpin everything else we do today. So once you can accept that and you're happy with that, you're ready for other similar questions. Okay, how about a question where we've got the mean, but we don't have the variance or the standard deviation? This is going to work in exactly the same way. First of all, I'd like you to try and do this one yourselves, because this will make you question what's going on and develop your understanding. First things first, strong advice to get a little picture of the normal distribution down. The mean is now 50. I know what that is. Brilliant. And I've got the probability that x is less than 46 is 0.2119. However, there's only one normal distribution that will give this, but I don't know what the value of sigma is. So that's the thing I'm trying to figure out. So I'm going to do a transformation. I'm going to let z equal x minus mu over sigma. I'm going to write it down generally to start with. I think this is always a good idea, but then it's going to become x minus 50 divided by sigma. And that is going to give me a new normal distribution. It's going to be centered at 0 again, because I'm minusing the mean from itself. Always going to get back to that. I didn't write this down previously, but remember that z follows normal distribution with mean of 0 and variance of 1. I should have said that in the first example. So this is going to be 0, but my 46 is going to become 46 minus 50, which is minus 4 over sigma. So that's my value there. And then this thing here is still going to be 0.2119. Brilliant, because now we can write down the probability that z is less than minus 4 over sigma is equal to 0.2119. And I can use the inverse normal again. It's already in the right format this time. So the area is 0.2119. I'm going with the standard normal minus 0.79984. I forgot what it was. 79984. Okay, rearrange this. Multiply by sigma, divide by the number, it's going to end up being, I can get rid of the negatives even, it's just going to be 4 divided by 0.79984. Remember, you're always going to get a positive value for the standard deviation. It has to be. Oops. Okay, so I'm going to need to do, I stored the minus. Maybe I should have put that in, but you can get rid of it because it's a double negative. Divided by a 5.00. Okay, so very similar question. Main question marks are probably like, why does this work? Why can we do this? But the method is there, and it's a case of practicing it, implementing it, trying to understand it. We're not actually done, are we? Because it then says find the 90th percentile of the widths. So we can finish this off, because what does it mean by the 90th percentile? It means I'm looking at the point 90% of the way through the data. So that's 10%, but it's actually easier to just say that this bit is 90%. So I'm going to call this A. It's the probability that X less than A is equal to 0.9. Back to my inverse normal. The area is 0.9. I'm now actually using my actual normal distribution. I don't need to do a transformation because I've got the mean and the standard deviation now. So the standard deviation was 5, or it was 5.00, but 5. The mean was 50. And there we have it, 56.4. I've got 90% of my values below 56.4. Maybe I should just write 90th percentile as well. Here goes then, the hardest sort of question you'll get on this. What if I don't know the mean or the standard deviation? To be able to find it, I'm going to need to have two pieces of information. And this feels like the most useful thing that you'd do in this kind of topic, because maybe I can imagine you might be able to get data on something and then try and fit a normal distribution to it. So this actually, I feel like has the most real world applications. Not that we're bothered about that, but just going to say that. Right, let's write down this information. So I've got mu. I think it helps to get a little sketch, and then I've got 35 here. And I've got a very small area, 0.025, 2.5%. I've got another piece of information, 15, it's going to be, because it's less than 0.5, it's going to be to the left now. And this area here is 0.1469. So what am I going to do? I'm going to do exactly the same as before. Let Z equals X minus mu over sigma. I should add where Z follows a normal distribution with mean 0 and variance 1, or standard deviation 1. Then, and you can just jump to it now, you can draw the sketch if it helps, but then the probability that 35 minus mu, hold on, that's not right. The probability that Z is greater than 35 minus mu over sigma, that's going to equal 0.025 still. Do you know what? I do like the sketches, I've got to be honest, because I just think you're less likely to make a mistake, because I'm going to remember that that's 0. And this is going to become 35 minus mu over sigma. And that's still the same area. Okay, I think it would have been easier to get this from looking at the graph. And then for the second one, it's going to be the same. It's going to be 15 minus the mean over the standard deviation, and that is still going to be, I think it helps to write this down to help you, learn the process. So the second one is going to be the probability that Z is less than 15 minus mu over sigma. It's going to equal 0.1469. Okay, I might get rid of these pictures now just to give me a bit more space. Right, what do we do with that? Well, and actually what we have in some kind of, it's not obvious maybe at the moment, but we have simultaneous equations. I've got mu and sigma in both equations. I just need to be able to solve them. Now the thing that I need to do is use the inverse normal distribution. So I'm going to use it on the first one. I'm going to need to change it slightly, so it's going to be the probability that Z is less than 35 minus mu over sigma. That's going to be 0.975. And then on there I can do my inverse normal on that. Whew. And I'm going to get 1.9599. Okay. And then with the other one, I can just put that one straight in. One 1.4669. How did it just didn't come out properly. Okay, minus 1.0498. Very important to just make sure you don't miss any digits out or write the decimal place wrong. Okay, and that was 15 minus mu over sigma. Okay, whew, this is looking better, I think. I don't know if you agree. Strong advice now. Get rid of the fraction. Let's just put a little line there. Right, multiply through by sigma in both cases. 35, we're on a roll now. 35 minus mu is going to equal 1.9599. I know I've rounded, but I'm working to 5 decimal places here. My final answer will be to 3, so this is fine. And then 15 minus mu is equal to minus 1.0498. Okay, simultaneous equations. And I forgot the sigmas on both. Right, I could put it back into kind of typical GCSE mode. I could add mu to both sides, but there's actually no need. I can just subtract these equations directly. Because I've got a minus mu and a minus mu, I'm going to subtract the left-hand sides. I'm going to subtract the right-hand sides. I'm going to get 20 equals whatever that is. I haven't stored these in my calculator. I could have done, but it's okay. And it's a minus minus, it's going to become plus. And there we have it, 3.00 or 3.01. Although I just remembered we haven't actually divided properly yet. 3.0098 sigma. And so sigma is going to be 20 divided by that, 6.64. Quite a lot to get that, but hopefully that will make sense. We're just implementing what we did at the start, and then we've got simultaneous equations on top of that. So for mu, I can substitute back in. Let me just show my steps. So I can substitute it into either one. Probably easiest to put it into this one because I can rearrange it to mu equals 15 plus 1.04 986 sigma. Sorry, I ran out of space there. So I'm going to times my sigma by this 1.04986, and then I'm going to add it to 15. 21.97, so 22.0. And we are done. Fantastic. I suppose just to be really careful, you could actually substitute this back in and check that the values work. So the probability that x is greater than 35. Let's just give it a go. Now, this is a good strategy for simultaneous equations, especially if you've got a bit of time. So normal CD. So what was it greater than 35? 6.64 and 22.0. And I get about 0.025. It's not perfect because I've rounded to 3 sig figs. So, you do expect some errors. But the fact that that works can just make you be pretty confident that you've not made a mistake along the way. And you could even check the other one if you wanted to. That last question was quite involved. It did just implement everything we did before, but the first time you see it, I think there's a lot going on. So to consolidate it, I want you to try this question that's very similar. All right, so we are not actually told about the distribution here, so I'm just going to let x follow a normal distribution with mean mu and variance sigma squared, just to get that out there. And then I can write down the probabilities in terms of it. So the probability that x is less than 35 is going to be 0.25 because it's talking about the quartiles here. So 25% of the way through the data, and then the other one's going to be 75% of the way through the data. Okay, how can we figure it out? Actually, there is a quick way to this, and there is the longer way. So I'm actually going to teach you the way that I've just done it. But if you fast forward to the end of the video, I'll talk about how you could actually do it slightly quicker. You might be thinking now, how could I do this particular one a bit more quickly? But let's imagine we didn't spot it. We're just going to go for it. So we need to do a transformation first of all. Actually, I might just label so I've got my mean here. I can put it all on one graph. And then I've got 53 and I've got 35. Let z equal x minus mu over sigma, where z follows a normal distribution with mean 0 and variance 1 squared. Then it's going to transform to this normal distribution at 0, and then 53 minus mu over sigma, and 35 minus mu over sigma. And then I've still got my 0.25 and my 0.75. So probability that z is less than 35 minus mu over sigma remains 0.25. Similar for this one. inverse normal. Zero 0.2510 minus 0.6744 inverse normal on the other one. Zero 0.6744. Aha, this is interesting. Oh, this kind of makes sense, doesn't it? Because there is symmetry in the lower and upper quartile, so we're expecting some sort of symmetry here, because it's going to be the same either side. Just like this is 0.25. This is, sorry. Anyway, I'm not going to talk any more about that, but like you can see maybe where these numbers have come from. We're nearly there. I can just multiply this out. Now, in this particular case, if you kind of spotted it, they are exactly the same but opposite. And probably the easiest thing to do is to add them this time, because then the sigmas are going to cancel out. You don't have to, you could subtract them, but I think adding is going to be the quicker way. So we can write down, so we can say adding the left-hand sides. Of course, you'd have to be really sure that they are the same exactly. I'm adding the right-hand side, so I'm going to get 0 here, and I'm going to get 88 minus 2 mu here. So I can see that mu is equal to 44. And this actually is where you can maybe see the quicker route to this question coming in. I'm just going to talk about it now, because the distance here is, how much is it? I'm going from 35 to 53, so the distance is 18. Now I know, because it's a symmetrical distribution, that these are exactly the same, and so the distance from the, sorry, I'm looking at the wrong graph here. It should have been this one. This is 18. Forget that. This is 18. So because it's symmetrical, and I've got the lower quartile and upper quartile, I've got 25%, I've got 25%, this distance must be 9, and therefore I can just do 35 plus 9 equals mu. This is a special case of this kind of question, where because I've got like symmetry in what I've been told at the start, I've been given the lower and upper quartile, I could have literally have just done 53 minus 35 equals 18 at the start, divide by 2 gives 9, added that to 35 and got the mean. I could have turned it into one of the first problems we did. However, I decided to go for it the long way because it's a more general approach. Of course, what I'm trying to say, I suppose, is if you can spot shortcuts in your maths, then of course use them, but make sure you got the general approach as well. So now I've got the mean, and it's exact actually, which is could be a problem if you might not get it exact if you kind of did it the other way from before. You might have had some decimal places, but that is going to be exact. I can sub it back in to get sigma. So sigma is then going to equal 35 minus 44 divided by minus 0.6749. Oh, I can store that. Okay, and I get 13.3. Nice one. I hope you're happy with this topic. do a bit more practice, really testing your understanding of the normal distribution here, but you can see it just slowly building up over time, and hopefully you're feeling in a good place about it. Well done. Sorry, one tiny error. I'm not going to do this whole video again because I've just spotted it. I've done all my working is absolutely fine. The only thing I've not done in this question is it actually asked me for the variance. So what I should have done is taken my value of 13.3 and squared it, 178. And this is this is a point to me. I still make this mistake, but also to you. Just make sure you do read the question carefully, that you underline the key things. Don't just like rush into it. It's asked for the mean, but in this case, the variance of the distribution. Apologies.